Okay, we are going to cover section 2.8 here. Going to start out with covering a concept called the difference quotient. Which the difference quotient is the expression f of x plus h minus f of x, all that over h. And we would say in this case h can't equal 0 because that would cause division by 0. And we're going to go through and we're going to solve, do a couple examples solving these. So first example, let's say they gave us a function f of x equals 3x plus 5. And they ask us to figure out part A. What is the f of x plus h, which is this part here from the difference quotient. Part B, they want us to say what is f of x plus h minus f of x, which is the entire top line of the difference quotient. And part C, what is the full f of x plus h minus f of x, all that divided by h. Okay, so we will go through and solve these. And let me so here's our problem, and we're going to go through and just do, we'll do some scratch work over here on the side. So for part A, if you want f of x plus h, what this says to do is replace the x value in your function with x plus h. So instead of getting 3 times x plus 5, we get 3 times, we're going to replace the x with x plus h. So we get 3 times x plus h plus 5. Next, what happens here is the 3 has to distribute. So we will get 3x plus 3h plus 5. And this will be our answer to part A. So part B wants us to take f of x plus h, which in part A we just calculated. F of x plus h was 3x plus 3h plus 5. And they want us to subtract from it the f of x term, which is 3x plus 5. So in order to do that, we'll distribute the negative sign here. So we will get this is equal to 3x plus 3h plus 5 minus 3x minus 5. And positive 3x and negative 3x, those will cancel. So 3x and negative 3x will cancel. Positive 5 and negative 5, those will cancel. And so for part B, the only part we're left with is 3h. So f of x plus h minus f of x is really 3h. Well, for part C, f of x plus h minus f of x, the entire top of this division, we just figured out that was 3h in part B. So we're going to be able to write 3h is the new top of the division. It's divided by h. You'll let the h's cancel, and you will be left with just 3. And that'll be kind of the process for finding the difference quotient in sort of the style that the homework asks us to find the difference quotient in. So the homework kind of spaces it for all its difference quotients. They say find A, B, and C in this manner, and then you go through find A, B, and C. So let's look at one that's a little bit more going on. So let's say f of x this time is x squared plus 3x minus 5, or so let's say like minus, 7. So let's say I want to part A, I want to find f of x plus h. Part B, I want to find f of x plus h minus f of x. And part C, I want to find the full difference quotient f of x plus h minus f of x, all that over h. So it's the same A, B, and C. I'm writing it a little bit different than I did in the first problem because this is going to be longer and there won't be enough room to kind of just write it out in the same space that I had here. So for part A, we're going to say, all right, we need to take our function f of x. We need to replace its x values. So I'm kind of creating with parentheses, creating spots to plug in. We need to replace the x values with x plus h's. So instead of x squared, I get x plus h squared. Instead of plus 3 times x, I get plus 3 times x plus h, then I get minus 7. So I'll need to set up to FOIL out the first term that's squared. 3 is going to distribute on this term. Then I'll eventually get the full expression. So for first, I get x times x is x squared. Outer is a plus xh. Inner is also a plus xh. Last is plus an h squared. Plus 3x plus 3h minus 7. Combine like terms, which really just is adding the xh plus the other xh. We get x squared plus 2xh plus h squared plus 3x plus 3h minus 7. This is my part A answer. This is f of x plus h. So a little bit longer than the previous one because we had to FOIL out the first term. Part B wants me to take this expression, this f of x plus h, and wants me to subtract f of x from it. So I'm going to recopy f of x plus h because I just calculated that in part A. So this is f of x plus h. And I'm going to subtract from it. I'm going to put my f of x function here. My f of x function is x squared plus 3x minus 7. So I'll put x squared plus 3x minus 7 there. Then we'll let the negative distribute. And we'll rewrite everything and see what's able to cancel. On the test or something, or on the homework, I'm okay if you do like the canceling up here in this step, but for the notes, I'll make sure to distribute so we're doing every single step by step. Okay, negative x squared and positive x squared, those can cancel. Negative 3x and positive 3x, those can also cancel. Positive 7 and negative 7, those can cancel as well. They add up to nothing. So what we are currently at is 2xh plus h squared plus 3h. This is the things that left over in part B that didn't actually cancel out with anything. Okay. Then part C wants us to take f of x plus h minus f of x, which we've just calculated in part B. And part C wants us to take that and divide it by h. So what part C says to do is take your part B answer, which represents f of x plus h minus f of x, all that over h, wants us to take that and divide it all by h. So when we do that, the h down here cancels with, you have to knock off an h in each of the top terms here. So this h cancels, and one of all the top terms, they need to be knocked down one h. So the 2xh, the h gets gone on it, so it's 2x. The h squared, you lose one h, keep the other. The minus 3h, the h is gone, the 3 is behind. And this is your answer to part C. So that is how the difference quotient works. So that'll be a few examples. You guys will have some like that on the homeworks involving the difference quotient. So we're going to move on to function composition. And we're going to spend the rest of the time looking at function composition. So what function composition says is if you have the expression f composed of g of x, that is equal to the function f evaluated at the function g of x. And this will be our equation that we're going to be using for the next little bit here. So what we're going to do is we're going to get some functions. We're going to focus first of all with what happens if you evaluate these at x, and then we'll work on what happens if you evaluate these at numbers, and then we'll look at kind of a mixture of them. And then that will pretty much wrap up what is in section 2.8 that we're gonna be responsible for. So we'll say for this example, let's let f of x equal 2x minus 1. Let's let g of x equal 3x, and let's let h of x equal x squared plus 3. I want to find part A, what is f composed of h evaluated at x. Part B, I want to find what is g composed of f of x. And part C, I want to know what's f composed of f of x. So for f composed of h of x, this is equal to the function f evaluated at the function h of x. So this will be the function f. H of x function, I'll write that out, that h of x is actually x squared plus 3. So now what we want to do is we want to take our f function, we want to replace its x value with x squared plus 3. So we get 2 times not x anymore. We're going to replace the x with x squared minus 3. So we get 2 times, it'll be x squared, x squared, I said minus 3, I mean x squared plus 3. 2 times x squared plus 3 minus 1. To finish this up, we'll distribute the 2. So we get 2x squared plus 6 minus 1 is 2x squared plus 5. For part B, we want g composed of f of x. This will equal g of f of x. So I'll say, all right, this is the g function evaluated at, and I'll write my f of x function. I'll write what it really is in here. The f of x function is really 2x minus 1. So I'll take my g function, which is 3 times the x, and I'll replace the x with 2x minus 1. I'll let 3 distribute, and I end up with 6x minus 3. That is my g composed of f of x function. Finally, for f composed of f of x, this is the function f evaluated at f of x itself. This will be the function f evaluated at f of x is actually 2x minus 1, so I write a 2x minus 1 in there. So I plug that 2x minus 1, I replace the x in the f function with that, so I'll get 2 times not x anymore. I'll replace the x with 2x minus 1. So I'll let the 2 distribute. I will get 2 times 2x is 4x. I'll get minus 2 minus 1. This will be 4x minus 3. Okay. So that is an example of what happens when you evaluate these, f composed of g of x or g composed of f of x. That's how to go through and calculate those. All right, so next example. What if we have numbers? Say f of x is equal to 4x squared plus 3. And let's say g of x is equal to 1 over x plus 4. And for part A, I want to say what is g composed of f, and the function f is evaluated at -2. In part B, I want to say what is g composed of -2. We already used -2, let's say. Oh no, it's g composed of -4, let's say. Actually, that causes problems. -5. Whoops, I forgot the other g. So g composed of g of -5. Sorry, that's what I want there. Okay, so we got these set up now. These are the 2 expressions I want. For g composed of f of -2, we say this is equal to what is g evaluated at f of -2. So I need to take my f function, and I need to replace its x here with the -2. So -2 is going to replace the x there. When I do that, I get this is g evaluated at -2 squared is 16. So we're going to do a little scratch work here. We get 4 times 16 plus 3. 4 times 16 is 64. Plus 3 is 67. So I get g of 67. So now I have to go to my g function, and I say in my g function, let me replace the symbol x with 67. And then I just total it up. So I get 1 over, let's see, 67 plus 4 is 71. Okay, part B. I need to say what's g of negative 5. So this is the function g evaluated at the function g of negative 5. If I put negative 5 in for x, I get 1 over negative 5 plus 4, which is 1 over negative 1, which is negative 1. So g of negative 5 becomes negative 1. So I have what's g of negative 1. So now I take negative 1 and I replace the x and the g function with that. So I get, it's 1 over negative 1 plus 4. Negative 1 plus 4 is 3. So this is 1 over 3 for my answer there. So if you evaluate your expression at numbers, you get numbers back. If you evaluate the expression at x's like we did here, or we had f of h of x, where it's of x, not a number, you get equations back. Okay, next thing that they're going to ask us, so we get a lot of problems with these types. The final type of problem they're going to ask us is they'll give us an f of x and a g of x, and they'll ask us, is f composed of g of x and g composed of f of x, are those the same thing? So let's say we have f of x equals 1 over x, and let's say g of x is equal to x plus 4. So we want to find is, sorry, an example, last example, is f composed of g of x, is that the same thing as g composed of f of x? Okay, so we're going to need to figure out what is f composed of g of x for this particular expression. So f composed of g of x, this is the function f evaluated at the function g of x. This is the function f evaluated at the g of x is just x plus 4, so this is x plus 4. So this will say take your function 1 over x, replace the x with x plus 4. So I get this is 1 over x plus 4. So this is my f of g of x function. So now I'll say, what about g composed of f of x? Is this going to be the same thing eventually? So this will be the function g evaluated at the function f of x. This is the function g evaluated at 1 over x. And then this will be 1 over x plus 4. So on one hand, we have 1 over x plus 4. And on the other hand, we have 1 over x plus 4, where the 4 is outside. These are different. If you all are having trouble seeing that these are different, we could say, like, imagine plugging 1 in. So these right here, we'll say these are not equal. These are not equal, so in this case, no, these are not the same thing. But if you are having trouble and you're like, hey, I'd like can you show me, so show me why they're not equal. So we could say show why not equal. Let's take a number like x equals 1. Well, if I put 1 in here, f of g of x, f of g of x is 1. If I put 1 into f of g of x's equation, I get 1 over 1 plus 4, which is 1/5. For g composed of f of x, if I put 1 into its equation over here, I get 1 over 1, which is 1, plus 4, which is 5. So these two functions send 1, these send 1 to different answers, so they're not the same function. So for x equals 1, f of g of x and g of f of x return different values. So they are not the same function. For two expressions to be the same function, for every single input, all their outputs have to match. And in this case, I found an input where this one sends it to one output, that one sends it to a completely different thing, so they're not doing the same thing. Okay, so that's basically all the main ideas you all will be kind of seeing in section 2.8, so we're gonna stop there, and we'll get 3.1 posted.